Hi, thanks for your interest. This is Xijie Qin. I'm gonna give a brief introduction to the integrated 2D beam emission spectroscopy diagnostic at HL-2A. The development of BES is motivated by the demand of measuring density fluctuations resulting from turbulence and other instabilities. The BES result can be used to study turbulence transport, pedestal instabilities, LH transition, and MHD mode structure and characteristics. The BES is designed to achieve 1 centimeter spatial resolution and 0.5 microsecond temporal resolution to study long wavelength turbulence. This system is installed at HL-2A tokamak, which has a major radius of 1.65 meter and a minor radius of 0.4 meter. HL-2A has many diagnostics and covers a wide variety of physics topics. So when NBI is injected to the plasma, the BES detects the d-alpha emission of excited deuterium atoms. The light is collected by a front-end optics and then transmitted through a fiber bundle to the lenses and then focused onto a photodiode detector. Compared with previously installed Phase 1 modular BES system, the Phase 2 integrated BES system has several advantages. First, it has 2 times more channels. Instead of having individual lens and filters for each channel, in Phase 2 integrated BES, 8 channels share a same 5-lens optical system. It also has 8 photodiode detectors and their preamplifier circuit packed onto one board. It uses TEC to cool down the detector to negative 20 degrees in Celsius instead of using chiller, which is cheaper and give better performance to the detector. Here is an overview of Phase 2 integrated BES system. The light is collected by the front-end optics and transferred through a fiber bundle to the commercial 5-lens system. And then the light is focused onto a detector module, which is controlled by the signal conditioner, and the data is aggregated by a digitizer. This process can be remotely controlled by a LabVIEW program. The front-end optics is designed with high throughput to minimize the transmission loss. The light is transmitted through a fiber bundle, which can be inserted into a flexible 2D fiber mount that covers 32 centimeter in radial and 27 centimeter in ploidal. The light is transmitted to a 5-lens optical system, where the filter is designed to have high peak transmission at full energy beam emission. After that, the light is focused onto a square photodiode. A projection of light on the detector from a single fiber is presented. 8 high quantum efficiency photodiodes are arranged in a circle. Their preamplifier circuits are packed onto a circular board. The detector is cooled by a TEC unit down to negative 20 degrees in Celsius with air cooling fan. The TEC unit is connected to a copper cold head where the preamplifier board is installed at. The signal conditioning unit provides variable voltage amplifier gain and control capability. The data is aggregated by a digitizer with 2 MHz sampling rate. A compact deck with built-in LabVIEW control program talks to the SCE and allows remote operation. The LabVIEW control program provides AC power control and system monitoring. It also sends out error message and warnings when something goes wrong. Negligible crosstalks between channels on the same detector board were measured. A crosstalk between 0.5 to 1.5% for channels in the opposite corners are measured, and the crosstalk are negligible for other channels. A noise spectrum for integrated BES at -20 degrees Celsius are presented. Compared with the modular BES, the integrated BES has lower noise level in general. High-quality density fluctuation data was obtained from experiment using the integrated BES system. BES data from shot number 37065 was analyzed. A time range of 1,100 to 1,250 milliseconds was chosen to avoid elms. The raw signal in time range are compared between adjacent modular BES and integrated BES. The D-alpha signal shows no elm events. The raw signal shows that the modular BES and integrated BES has similar magnitude, fluctuation, amplitude, and behaviors. The auto spectrum was obtained for integrated BES channel. After NBI was turned on, signal at high frequency was observed, and higher NBI power leads to stronger signal. The auto power, cross power, and noise spectrum for an integrated BES channel are presented. Cross-power analysis between poloidal adjacent channels were performed. High coherences were observed at frequency range of 20 to 200 kHz. A clear slope was observed for cross-phase. Those results indicate that BES successfully measured the changes of local turbulence. Cross-correlation coefficient functions were calculated. 150 millisecond BES data was split into 720 millisecond segments, and their maximum correlation coefficient and time delays were calculated. Results are statistically consistent with a small standard deviation. The calculated maximum correlation coefficient and time delay can be used to derive turbulence characteristics. An example of cross-correlation analysis between 5 radially separated channel pairs is presented. The decreasing maximum correlation coefficient with increasing distance is consistent with expectation. An example of estimating the turbulence characteristics, the radial correlation length, is presented. Summary. This new integrated BES system has been installed at HL-2A and collected data from experiments. The noise spectrum for integrated BES is obtained and is lower than modular BES in general. Comparison of raw signals between adjacent modular BES channel and integrated BES channel shows that they have similar magnitude, fluctuation amplitude, and behaviors. High-quality density fluctuation data were obtained from experiments using the integrated BES system. Cross-power analysis showed high coherences and clear slopes of crossfades between the adjacent channels, indicating that BES successfully measured the changes of local turbulence. Statistically consistent cross-correlation results were obtained and can be used to estimate turbulence characteristics. In the future, we plan to perform velocimetry analysis. The related coding work is in progress. We are building a BES data analysis tool that's shared and maintained by a group of people. We are also designing a phase 3 integrated BES system with either 32 or 64 channels. That's the end of this poster. You can find more detailed information in this poster and the references. So thank you and stay warm.